Hi, I'm Mr. Huber, and in this video we're going to talk about exercise 1b. Look, this is 4 and this is 2. 4 could be written as 2 to the 2 to the x minus 2 to the x times 2 to the 1 is equal to 48. Then you could write it as 2 to the x to the 2 minus 2 times 2 to the x, and let's subtract minus 48, or let's subtract 48 and you get minus 48 is equal to 0. And now you can see that this is a quadratic equation in 2 to the x. So we can substitute z as 2 to the x. So z to the 2 minus 2 times z minus 48 is equal to 0. So now you can solve this. It's z minus 8, z plus 6 is equal to 0. You could use the formula if you wanted. So z is equal to 8, z is equal to minus 6. Then let's resubstitute. 2 to the x is 8. Well, 2 to the x is 2 to the 3, so x must be 3. And here, 2 to the x is minus 6, so let's use the ln on both sides. So ln 2 to the x is equal to ln of minus 6. Well, this doesn't work. Why is that? Because the ln function looks like this. The domain of the ln function is r plus, and minus 6 is not in that domain. Minus 6 is not an element of the domain, which means this cannot be solved. So this is the only solution. The solution set is 3. Please, look, we tried to make it look like a quadratic in 2 to the x. We were able to rewrite 4 with a base of 2, and we were able to use to rewrite this by using the laws of indices. We were able to write it as a quadratic equation in 2 to the x. Although this is not a quadratic equation, it's not a quadratic equation, but you're able to write it as a quadratic equation in 2 to the x. Well, and that you substitute by z. So you work out your z's. Once you have worked out z is equal to 8 and z is equal to minus 6, you resubstitute these two values and you work out x. And this is how you get to your solution. X is equal to 3, the only solution, and the solution set is now 3. Hope it wasn't too difficult. See you on the next one.